Okay, so let's get started on, I'm Carl, K9LA from Fort Wayne. So I got a long drive tonight to get back, that's okay. Got a Sirius XM in the car, so I can listen to anything I want to. I'm going to talk about cycle 25, talk about space weather, all those parameters out there, and then talk about sporadic starting and also field days coming up. Do you guys do field day at all? No, NIDXA doesn't. No. Well, the season's starting and you can get on and all that stuff.
There's no DX on field day.
Oh, okay. Yeah, DX. That's the best day to operate. Okay. One thing I like in ham radio, other than DXing and contesting, I was a contest editor for 5 years. I'm not sure which is tougher, hurting a bunch of DXers or hurting a bunch of contesters. I think it's contesters are kind of tough. Okay. But I also like vintage equipment. And there's one of my vintage stations. I'm sure everybody knows that's a Ranger 2 and a Dream 2. Yeah, and a D104. And a D104 and some old headphones that hurt after, you know, J38 key. Yeah, that's right. Now, here's a recent addition to the K9LA shack, a KWM2. Now, it needs some work, but I'm sure I'll get it going. And wow, I'm a Collins owner now. You guys can bow down anytime you want. Well, the 2B is where it's at. Oh, that's right. Yeah, that's right. Okay, so what we're going to talk about, that thing's good. Okay. Let me look at that. Meeting audio is muted. No, I'm not. Okay. Whatever. Okay. Talk about cycle 25, a little about historical. You know, what did the last 24 cycles do? Talk about predictions. I'll go over 2 methods of predicting a solar cycle, and then we'll look at the latest data. Of course, predictions are great, but real data trumps all of the predictions. Talk about space weather, not weather, space weather. What parameters should we pay attention to, and what do we want those parameters to do? Then I'll look at some ways for assessing real-time propagation. You probably are familiar with all of them, but what I thought I'd go over them. And then talk about sporadic E, the short-term patterns and long-term patterns. Okay. Come on. There we go. Cycle 25. How many remember Jeeves from QST? Oh my gosh, yeah. Great. Every once in a while they show up again. So here's a look at all 24 solar cycles. That's an Excel plot. It shows the maximum smooth sunspot number for all 24 cycles. Cycle 1 began in 1755. Anybody around? No? Okay. Even I wasn't around. You've probably heard of a Maunder minimum. That occurred in 1645 to 1715. There were few sunspots. 1755 was about when solar scientists said, yeah, we think our data is good enough, so let's start there. Now, what's really obvious from that plot is we've gone through 3 periods of big solar cycles. Cycles 1 through 4 were kind of big. Cycles 8 through 11 were big. And then our lifetime, cycles 17 through 23, probably no 17s or 18s here, but certainly some cycle 19 guys that have been through cycles.
When was cycle 19?
It peaked in 57, so it started probably in 54 or something like that.
It's the first year I was alive.
Geophysical year. Yeah, it was 57, IGY. Had to think about that a while. So we've been through 3 periods of big solar cycles, and what that also says, we've been through 2 periods of small solar cycles. Cycles 5 through 7, they were kind of small. Cycles 12 through 16 were a little bit bigger, but they were down there too. And of course, cycle 24 came along, and it's way over there on the right. And well, it's the smallest in our lifetimes. It's the 4th smallest in recorded history. So the big question is cycle 25 going to get us out of this third period of small solar cycles or keep us in? So let's look at some predictions. Hey, things working. Now I'm aware of 56 predictions for cycle 25. 56, why are there so many? Well, we just don't fully understand what generates sunspots. We know it's how the magnetic fields move inside the sun and how plasma moves inside the sun, but we just don't have all the nitty-gritty details. So there are many different methods for predicting solar cycles, and you can see that's a distribution of all the predictions. In other words, way on the left here, there's one prediction for a smooth sunspot number between 25 and 49. So the predictions go from a very low cycle to a very high cycle. Cycle 24 had about the same amount. So we haven't learned a heck of a lot about the inside of the sun yet. Of course, it doesn't help that solar cycles are so long, about 11 years. So if you make a prediction, it could take a while to validate your hypothesis. So if you look at that distribution, you'll see 50 of the 56 predictions, 89%, are for a below average solar cycle. Now, cycle 23 was an average solar cycle, and 3 are for an average solar cycle. We'd be happy if we get an average solar cycle, I believe. And 3 are for a larger than average solar cycle. Anybody familiar with Dr. Scott McIntosh? He and his colleagues predicted a really big cycle, and you can I put an arrow from that to which bucket it falls in, and that's their original prediction was for a very big cycle, not as big as cycle 19, but it was certainly up there. But last August, they revised their prediction down to about an average cycle. And that's because an event that they expected to happen earlier didn't happen on the sun. What's going to happen? I don't know. All we can do is look at the data to date and take a wild guess. So I thought I'd show one way to predict a solar cycle. What that plot is, it shows when the smooth sunspot number was below 20, how long it stayed below 20. You can see on the left, there are 5 solar min periods that lasted about 24 months. And those were all, that was cycles, between cycles 18 and 19 through 22 and 23. In other words, we got very used to very short solar minimum periods, only about 2 years. But then the minimum between cycle 23 and 24 came along. That's the green plot. And it was below a smooth sunspot number of 20 for almost 5 years, about 4.5 years. Now, what about the minimum between 24 and 25? That's the red curve. It lasted a little bit longer than the minimum between 23 and 24. Let's take a look at how long solar minimum was versus how big the next solar cycle was. And there's that plot. And what it obviously shows is the longer you're at solar minimum, the smaller the next cycle is going to be. Now, the correlation coefficient R is 0.767. Well, that's pretty good correlation, but it's not perfect. 0 is no correlation. All the data points would be scattered about the red trend line. If the correlation was perfect, it'd be R would be 1.0, and all the data points would be on the red trend line. So it kind of suggests that we're going to have another small cycle. Suggests. That's all we can say right now. The sun will do what it wants to do, not what we expect. There's another thing. What about how low does a solar minimum get down? We saw that on the previous couple. Some solar cycles got down to a minimum smooth sunspot number of about 3. Some, well, they were up at 10, 12, and a little bit higher. So is there a correlation between how low solar minimum was and the next solar cycle? Well, if you do that correlation, there seems to be a trend that the lower the smooth sunspot number is at solar minimum, the lower, the smaller the next cycle is going to be. Now, again, it's not perfect correlation. In fact, it's worse than, it's about 0.567. So again, we could just take that with a grain of salt. So again, we'll just have to wait and see what happens. So here's the real, now here's something that I've seen a lot of, that cycle 25 is well ahead of the NOAA prediction. I've seen that several times. And here's a plot that came from the Front Range 6-meter reflector. They put it on there for their Groups IO people. And why people say that cycle 25 is well ahead of the NOAA prediction is because NOAA predicts that cycle 25 started in June 2020, which is the light blue, the bottom solid line here. But the smooth sunspot number numerically minimized in December 2019. So I don't understand why they didn't start their cycle 25 in December 2019. So if you shift this light blue line 6 months to the left, and that's the blue, the dark blue line, you can see that it's a little bit better than the prediction, but nothing great yet. So let's take a look at what the real data says. So the red heavy line, that's the progress of cycle 25. We have 23 months of smooth sunspot numbers. The green line is what cycle 24 did. Cycle 24 was pretty small, it's the smallest on our lifetimes. Okay. The orange plot is cycle 25, which I mentioned is an average cycle. And then cycle 21, which peaked in 1979, that's the blue curve, and that was a moderately big cycle. It was a good one for 10 meters and 6 meters.
10 meters used to be open all night long.
Oh yeah, yeah. And it's too bad we didn't have as many 6-meter rigs back then. It would have been really good. But you can see what cycle 25 is doing. It's doing a little bit better than cycle 24. Of course, it's still too early to say what's going to happen. Maybe in the next 6 to 12 months, we'll have a much better idea where it's going. But if I had to put a nickel down, I'd bet on a small solar cycle. But, you know, take that with a grain of salt. Now, the bottom line is we need more sunspots for daily worldwide propagation on those higher HF bands, 15, 12, and 10. You know, we get openings occasionally to Europe on 15 and 12, even 10 meters, and good north-south openings. But for that to happen on a daily basis throughout the world, we need more sunspots. We just got to wait for cycle 25 to keep going up.
But just 10 months ago, according to this and what I was watching, because I watch it every day, is that we had 0 sunspots.
Yes.
So 10 months ago, we had 0, and this morning it was 190, I think.
Yeah.
So that's really nice.
Yeah, things are going up, and kind of hard to say this, but this may be the last solar cycle for many of us.
You had to bring that up.
I had to bring that up. Sure. Well, except for CJ. He might be around for 26.
I don't know about that.
Well, I hope you are. I hope you are. Okay. Now, while we're waiting for cycle 25 to move up more, what we can do is kind of look at a year-long worth of data, and that's what that is. That comes from that solen.info/solar website. And the data is from May 3rd of 2021 to May 2nd. That's when I pulled it, of 2022. what it does is shows the daily 10.7 centimeter solar flux in, oops, oh shoot. I wasn't supposed to do that. Yeah, I did it. Okay, oops. The daily 10.7 centimeters solar flux is in black. The daily sunspot numbers in red. The blue is the daily A index, which tells us how active the Earth's magnetic field is, which probably gives us a good hint at how screwed up the F2 region may be. But you can see way over on the left, we were coming out of solar minimum. So there weren't many spikes. Things were kind of quiet, but as we're moving to the right, which is later and later time-wise, we're getting more and more spikes. So one thing we should watch for is when the solar flux and the sunspot numbers spike up, go take a look at the higher bands. Where was it? Right here. This was CQ Worldwide DX Phone in 2021. That was a very good contest on the higher bands. And that's because the sunspot numbers spiked up and the solar flux spiked up. So that helped. And of course, we have to remember those are just proxies for the true ionizing radiation in the F2 region, which is extreme ultraviolet radiation. So keep an eye on that. It may tell you that, hey, things, it's time to look at, look at the higher bands a little bit closer and see what's going on. What about space weather? There's sure a lot of parameters out there. I'm going to get through this pretty quick. Unfortunately, I'll mention solarham.net, but that's not the one I'm looking at. What I look at is the N0NBH banner. And it's put together by, well, N0NBH. How about that? And this is the one from QRZ.com. It's also at other places. Might even be at solarham.net. I'm not sure. Well, whatever. Okay. And so the parameters that we probably should pay attention to the most are SFI, which is the solar flux. SM is the sunspot number. And those are enclosed in the gold boxes there on that banner. I also highlighted at the bottom the MUF US Boulder. What that is the maximum usable frequency over the Boulder ionoson. If the Boulder ionoson's at the midpoint of a 3,000 kilometer path. Now, what that means is the path from the Midwest to California is about 3,000 kilometers. So Boulder's in the right place. So if you look at that, on the day I pulled it, which was May 3rd, the MUF over the Boulder ionoson was 19 megahertz, which means 17 meters, probably was open to California. It's a good indication of kind of what the MUF is doing in the continental states too. If the path is north of Boulder, then it's smaller. If it's south of Boulder, it's probably a little bit higher because we're approaching the equatorial ionosphere, which is the most robust portion of the ionosphere. And there's some kind of some numbers that to look for. For example, when the solar flux is 90 for a long time, in other words, the ionosphere's kind of got to build up. So we want the solar flux to be greater than 90 for a long time. Then that should give us daily and worldwide 15-meter propagation. You can see what 10 meters and also relating it to sunspot numbers. Now, what about stuff that can screw up the F2 region? Well, the K index. That's a 3-hour index. It tells us how active the Earth's magnetic field is. Generally, we'd like to be less than or equal to 3. It goes from 0 to 9 on a logarithmic scale. K equals 0 is very quiet. K equals 9 is a very disturbed F2 region. I should mention the A index, which is the average of the 8 3-hour K indices. So it's a little bit coarser picture of what the Earth's magnetic field has done over a 24-hour period. but I think we all prefer to look at the 3-hour K index. BZ, that's the Z component of the interplanetary magnetic field, which is the sun's magnetic field. The Z component, it's perpendicular to the ecliptic. What's the ecliptic? Well, that's the plane in which the Earth goes around the sun. So perpendicular to the ecliptic is kind of north-south. And that's what the Earth's magnetic field is, north-south. So when that Z component is positive or slightly negative, that says the sun's magnetic field, solar wind stuff, isn't coupling into the Earth's magnetic field. But when the Z component gets highly negative, that's when things can be bad. And that's when the F2 region can get screwed up. SW is the solar wind. On average, it's about 400 kilometers per second. And it can range from 0 to, or not 0, but maybe 300 kilometers per second. Although there was a period in time when there wasn't any solar wind. I don't remember what was going on there, but whatever. Maybe the sun had COVID or something, I don't know. But in general, we don't want it to be too much greater than 400 kilometers per second. Now, the K index, if it's high, generally is going to mean the Z component is going to be large negative, and the solar wind is going to be, a bunch of kilometers per second. So that's what we want. Now, that's just looking right at data. W9JJB, right? Mentioned solarham.net by VE3EN. He has the same data, I believe, but he also has a lot of images too, which, if you like numbers, if you like images, take your pick. Now, one thing I'm going to say is, even though those numbers, we can translate those numbers to kind of what the propagation in general looks like, it still may not tell us what the bands are doing right now. Now, a good example of that is if today's solar flux is 80, and if tomorrow's solar flux turns out to be 100, that doesn't necessarily mean the bands are going to be better. There's other factors that determine the ionization in the F2 region. There's geomagnetic field activity, so the K index will affect it. Also, events at ground level and the lower atmosphere, they can couple up to the F2 region and cause variation too. So we don't fully understand these events. We know volcanoes and hurricanes, and we're coming up on the 42nd anniversary of Mount St. Helens, May 18th. It caused perturbations in the F2 region. Now, how much did that affect propagation? I'm not too sure. It might have been a local kind of effect. But then you have to look at how much all that ash spread around the world, and did that do anything? But so if you want to know really what the bands are doing right now, go to dxmaps.com. That's one of the places. I selected a world view. You can select bands from 2,200 meters, 137 kilohertz, to above 432 megahertz. And I picked, I downloaded this May 3rd. I looked at 15 meters. And there's who is working who from 1420 to 1420 UTC on May 3rd on 15 meters, which is kind of early in the morning. North America was working South America, working South Africa, working in the Pacific, working so you can also look at 6 meters and see what's going on. The other methods, the KC2G has a MUF map. Yeah, we'll go over that in the next slide. PSK reporter, you've probably heard of that. You can get maps of what's going on. WhisperNet, same thing. See, where is he? Oh, there he is. Had a good discussion about the balloons that the Northern Illinois bottle cap balloon battalion or whatever is launching, and they have the new transmitters are 20 meter whisper, running a whopping 10 milliwatts.
You get 2,000 miles.
Yeah, so interesting. There's also the reverse beacon network. If you transmit in a certain format, you can look at software-defined radios around the world and see where you're being received. That'll give you a pretty good picture right now what's going on. Also might be a good way to test two different antennas too. Transmit, move a little bit in frequency, transmit again. Wow, this one's better, that one's better. And of course, the IARU and Northern Cal DX Foundation beacons, there are 18 worldwide. There's some more coming online. Each of the 18 beacons transmits in a 10-second slot. So 180 seconds, 3 minutes, you can tell what worldwide propagation is on any of the bands, 20, 17, 15, 12, or 10. There's also software by VE3NEA called Pharos, F-A-R-O-S. It syncs your PC to the radio, so you know which beacon is transmitted in that 10-second slot. And you can take data, you can plot data, get lots of good information. I mentioned that KC2G. What he does is he downloads worldwide ionoson data. That's what the circles are with the numbers. That's the MUF, assuming it's the midpoint of a 3,000 kilometer path. He adds contour lines connecting equal values. And that data is updated 15 minutes because it's tied to the cadence of the ionosons. They take data every 15 minutes. Some take it every 5 minutes, but he had to pick the 15 minutes. That's the longest one. I drew a 3,000 kilometer path between Chicago and the Southern Caribbean. And you can pretty much pick out what the MUF was at the time I did this. And that'll give you a good idea what's going on the band. Also, you can select printing the critical frequency of the FOF2 region, which FOF2 is the MUF for very high angle. So that's a good indication of what NVIS is doing. If you're working NVIS DX, yeah, right. I don't know what that is. So here's just a quick picture of where disturbances occur when the F2 region gets screwed up, and the D region too. We have to take the bad with the good. The bad is we're going to see more solar flares, more CMEs, coronal mass ejections as cycle 25 rises, but we're going to get more extreme ultraviolet to ionize the F2 region. So we got to take the bad to get to the good, and that's just the way it is. The coronal mass ejections are most prevalent around solar max. Big solar flares are most prevalent around solar max. And the big solar flares can cause two disturbances. One is a solar radiation storm. That's when the flare emits very energetic protons and they funnel into the polar cap and screw up our over the pole paths. The big solar flare can also emit X-ray radiation, and that'll increase the D region on the daylight side of the Earth. So the coronal mass ejections probably are the worst because they can affect the F2 region for a longer period of time than the big solar flares. Coronal holes, they're most prevalent on the decline of the solar cycle, so we got to wait before that starts again. But those are really not very good either. I kind of indicated with the green annotation where we kind of are in the solar cycle, 25, and we're really in the quietest time of a solar cycle. That's for what it's worth. Sporadic E, well, here comes field day, whatever. Short-term pattern, you're probably familiar with this. There's some very old data from 57 and 58, but it's still relevant on the probability of sporadic E versus month and versus local time. The green shading is just the maximum probabilities. And in the summer months, of course, we should look late morning and early evening, but don't forget in between, because the probability isn't zero. And I'm sure there'll be lots of DX worked on 6 meters via Sporadic E this summer, and probably on 10 meters too. How about long-term patterns? Back in 1992, W3EP and WA5IYX had an article in QST, and they looked at 11 years of Sporadic E data in the FM broadcast band. And that's kind of close to 6 meter, kind of. But here's a chart showing, or a plot showing the bars, the vertical bars are the total minutes each year for Sporadic E observations. The dotted line is the 10.7 centimeter solar flux. The solid black line is the A index. And you stare at it long enough, and Sporadic E doesn't seem to have a correlation to a solar cycle. So it's going to happen pretty much throughout a solar cycle. And even the A index isn't too strongly correlated. Now here's a more recent analysis of Sporadic E. This was by VE3EM, the solarham.net guy. It was from 2004 to 2014. And what he did is monitored Sporadic E on 6 meters between Eastern and Western Europe in the eastern half of North America, which was call areas 1, 2, 3, 4, 8, 9, and also those VE call areas. And he only recorded data when there were 5 or more contacts between multiple stations. So it just wasn't a, one guy worked something and that was it. It's multiple contacts. And the y-axis is the percent of the 11 years that QSOs were made. So you can see in June and July, many of the years had, the days of many of the years had good east of best stuff. So cycle 25 is in its ascent. Probably the maximum will be around 2024, 2025. So far, let me say that again, so far, it looks like another small cycle. It could accelerate and get higher. It'd be nice if it made it up to an average cycle. We'll see. But even if it is a small cycle, remember cycle 24, it still had great worldwide propagation on the higher bands and even on 6 meters around solar max in the fall and winter months. So even if cycle 25 is small, 25 it should have some good propagation, just won't be as long. The number of years won't be as long. Of course, the digital modes offer an advantage over sideband and CW because they can decode a signal farther down into the noise. And of course, that's a significant advantage on 10 and 6. Our last solar minimum is probably the most active on the higher bands, 15, 12, and 10 meters because of FT8. If you ever look at Club Log, they have weekly statistics of how many QSOs were reported on FT8, on CW sideband, and a bunch of all the other modes, FT4, JT65, and FT8 is more than all the other modes by a long shot. So FT8 has taken over ham radio. Well, that's a statement. That's all I can say. The Sporadic E season has started. I've seen spots on 6 meters even, and watched 10 and 6. And there are tools on the internet to determine what the bands are doing right now. And that's all I had. So if there are any questions, I can answer them, hopefully, maybe.
Carl, it looks like I saw your chart here, and I saw one the other day that showed the ascent of 25 is way ahead. I mean, it seemed like the chart's going almost straight up in terms of number of, I mean, we were at such a low minimum.
Yeah.
At 0. I mean, some days were just 0.
Yep.
And in the bottom of cycle 24 and ending cycle 24, hopefully beginning. I mean, how can they say cycle 25 started in 2019 when we were at we were at 0.
It was, well, it was 1.8, but that's right. Yeah, well,
What's the time frame for, you're saying 1.8, but I mean, there were many days when there was nothing.
no, but remember now though, we use a smooth sunspot number, which is not a daily. When you take the daily sunspot number, average it over a month, you get monthly means. Then you average 12 of the monthly means. And what you're trying to do is smooth out all the spikiness. So all we talk about.
No, what I want is a spike test.
You want the smooth to go up too.
Yeah, true.
Yeah, so that means more.
I'm just kidding, Carl.
Yeah, well, you can see right here that cycle 25 is mostly following 24 right now, which kind of suggests a small cycle. I don't know what to say.
Yeah.
I'm going to give my prediction for cycle 25 in 2024. Okay.
Carl, what about the F2 on 6 meters? When would that happen and what has to?
That would happen around solar max during the fall and winter months. The fall and winter months are best because the atmosphere changes during the seasons. And the F2 region can be more highly ionized in the fall and winter because of how the atmosphere changes. So look in the fall and winter around solar maximum. We still got a way to go for 6 meters, that's for sure. But I'm sure it'll be there. Maybe not as big as you want or as long as you want, but it'll be there.
Carl, on like DX maps, they're watching 6 meters and watching the clouds.
Yep.
How do they get that data so real time? Where's it come from?
From spots, like on packet cluster. Yeah.
Not just map lines, the sporadic E clouds, the MUF.
Yeah, the MUF clouds that are.
Oh. Probably they're just looking at where the, where the paths intersect.
Okay, you're saying
Maybe where the cloud is.
Probably. It's derived from the QSO data, so basically.
Yeah, and there's some guesswork in there.
Okay.
We can't measure that consistently right now.
Well, it looks like the possibility that 25 is going to be small. If you look at the patterns of the cycles, 24 was small, but that was the first one.
Yeah.
And the small cycle things usually go for 2 to 3 solar cycles.
That's right.
So we've only had one,
Yep.
which suggests that 3 more. This is still going to be in the small,
Yep.
and maybe the one after it.
Yeah, that's right.
If that cyclical thing.
Yeah, who knows? Maybe the sun will change and something will happen and then we'll have a bigger cycle.
So does this mean I can't get 300 DXCC on 160 through 10 now?
Not at all.
I think you'd have a problem with 160 the way things are going.
Yeah.
Everybody's on, unless you use FT8.
I thought I saw something recently too, though, that showed, was it the sun's magnetic field is weakening?
Yes. Yes.
What does that mean? Is it the end
That
of the
means less sunspots.
Gonna click off
life as we know it?
Oh, I don't think it's the end of life, no. No, that won't happen, I don't think, but, well, that's like the Earth's magnetic field is weakening, which is probably leading up to a flip of the magnetic field, which that's gonna screw us up, isn't it?
If that happens, your tax bill won't matter that much.
Yeah, right. Yeah. I take it going east, yeah, you'll be going west to get to Fort Wayne or something.
We had on that chart, actually, 5, 6, and 7 were extremely low.
Yeah.
Did they have the same means to measure sunspots back then?
Well,
Is that accurate compared to what we're doing today?
we think it is. The telescope improved over all those years. And we have a good formula for calculating the sunspot number. It's not just how many spots there are. The groups of spots are weighted more than the individual spots. So I assume that happened, or at least we went back to the old data and got that all right. Yeah.
Because there's such a wide difference. See, some of those high 3 and 4 end down the tubes.
Yeah, well, I think we're pretty sure that the sun has gone through those cycles, whether it does so in the future, I don't know.
I would predict cycle 25 is going to be one of the best cycles we've seen. Not necessarily just because of sunspots, but because there's more people with more sensitive receivers. In the past, how many times was the band open and nobody was freaking on the air? It was like, I didn't make the first call, right? So it seems like there's a much broader number of people listening, monitoring, calling CQ on the digital modes with more sensitive receivers. Guys that are got a 100-watt piece of wire out of a hotel room in some foreign country, they can actually start working DX, where before maybe they would talk around in the country only. So I think for a DXer, this is going to be a great cycle.
It may not be a big cycle, but it's going to offer a lot more activity because of the technology. Yeah.
All in the same 3 kilohertz.
Yeah, right. There you go.
If you look at the last 5 years, and John does the DX marathon every year, and we've been hitting 230 to 250 countries a year, every year, with crap conditions. We just want to know, Carl, those were crap conditions, and we're still doing that. And God knows, I just hit 220, I think, this morning on countries for this year, which is way ahead of last year. I was probably at 130 last year or 140, something like that.
Is that the same most
times? Well, it varies. I'm doing a lot more sideband now.
Okay.
In the evening and getting on and talking to people. I love talking to people. The digital modes are great, but I really like sideband a lot. So that's, where my love is. So it's just absolutely wonderful to get on the band on 20 meters at 10 o'clock at night and work A71, A61, A41, and, Bulgaria and all the guys are on, and that's just great. I mean, that's just perfect.
How many here worked a week ago or 2 weeks ago, JT1CO on 15 CW?
I worked him from my house with 1,000 watts and a wire, and I was extremely ecstatic because that's my last zone.
Yeah, he had about an S9 signal in Fort Wayne, and I just got a small tri-bander at 40 feet. And
that was an amazing opening.
He's a good op too on CW.
Yes.
Yes.
Carl, you had a slide on, I don't remember what it said, but something about on the descending of the cycle, things get quieter. What was that?
No, they get, that's when window disturbances occur. Actually, where is it right there?
Quieter ascending.
Yeah, ascending portion is quieter.
Oh, okay.
The coronal holes are worse than CMEs. They're going to screw up the F2 region more on the descending part of the solar cycle. So we got a way to go before that happens.
How do you evaluate them? How do you figure out, you see them on the map, but they're on the globe?
Yeah, well, it gets back to, we still can't take all those space weather parameters and map it to a unique state of the ionosphere. All we can see is talk about is trends. If the K index is going up, that means the BZ is going more negative. Solar wind's probably going up, and that means the F2 region is going to be screwed up. There is a model out there by, it's on the Space Weather Prediction Center website. It looks at the last 11 K indices and tries to predict what the F2 region is going to do. it's the best model we have at the time. And still, there's probably more we need to know and learn.
Okay. Any more questions before we close her out? Thank you, Carl.
You're welcome.
Thank you.
Stop the recording.